Welcome everyone. Today, through this video, I will discuss about a topic of matrices. The topic is adjoint of a matrix. This topic is most important topic for board exam and competitive exam also. In board exam, you get a problem. In competitive exam, you also get a problem from this topic. So, adjoint. Adjoint of a matrix, we know adjoint of a matrix is transpose of cofactor matrix. Transpose of cofactor matrix. A is any matrix. A is any matrix. Any matrix. We consider here third order matrix. So C11, C12, C13. Cij are cofactor of Aij. So cofactor matrix. Then transpose. This is called adjoint of a matrix. So we consider first the basic concepts. Then I will solve some problem of this topic. So property 1, A into adjoint of A. Adjoint of A equals to adjoint of A into A equals to determinant A into I. So this is property 1. We know matrix multiplication is not commutative in general. But if we take a matrix A, suppose second order, 1, 2, 3, 5, and if we find adjoint of A, A, this is 5, this is minus 3, this is minus 2, this is 1, then transpose. Then 5 minus 2, minus 3, minus 1. Sorry, minus 3, 1. So interchange of the diagonal elements. So then change of sign of this element and this element. And if we multiply this, then A into adjoint of A equals to adjoint of A into A. So matrix multiplication is associative in this case. So if it is given in board exam, give an example for which matrix multiplication satisfies associative law. Then you take any matrix and take adjoint of A, then take multiplication A into adjoint of A equals to adjoint of A into A. So this is property number 1. Property 2, not in this order also, adjoint of AB equals to adjoint of B into adjoint of A in reverse order. Adjoint of A transpose equals to adjoint of A, then transpose. And these 4, 5, 6, most important for short question for board exam. Determinant of adjoint A equals to determinant A to the power n minus 1, where n is order of matrix. Order of matrix. So this is most important property. Property 5. So adjoint of adjoint equals to determinant A to the power n minus 2 into A. We are not giving the proof, we only remember the result. So you can, for proof, you can consult any standard book. Then determinant of adjoint A. equals to determinant a to the power n minus 1 whole square. What is n? N is order of the matrix. And adjoint of K equals to k to the power n minus 1 into adjoint of A. So we use these results. So these are basic ideas. Now we try to solve some problem relating the topic adjoint of matrix. Now we consider 1 marks problem, some 1 marks problem based on the previous theory. The value of 3 into 3 determinant is 3. So problem number 1, 3 into 3. So determinant A equals to 3. Then determinant formed by cofactors. So determinant of cofactor of A. So cofactor of A, determinant form, cofactor. So adjoint of A equals to cofactor of A, then transpose. So cofactor of A, if you take transpose, adjoint of A, then transpose equals to so cofactor of A. So cofactor of A. So this is adjoint of A transpose equals to cofactor. So this is determinant of adjoint of A, the transpose. So determinant of transpose matrix equals to determinant of A equals to determinant of A transpose. We know is well-known property. Now it is adjoint of A. So determinant A to the power n minus 1. So n is 3. So determinant A whole square. Now what is A? A is 3. So 3 square, this is 9. Look again. A, determinant A, this is given 3. Value formed by cofactor. Cofactor of A. So adjoint of A transpose. So adjoint of transpose determinant equals to again adjoint of A. So this is 9. Number 2. This is problem of JEE main. A is 3 into 3 matrix. Then which one is not true? Now, adjoint of adjoint. So there is well-known property, you know, determinant A to the power n minus 2 into A. So determinant A into A. So adjoint of A is this one. Adjoint of adjoint A. So this one is true. Now, A inverse equals to, we know, adjoint of A by determinant A. So what is adjoint of A? A inverse into determinant A. So this one is also true. Now, adjoint of adjoint A. So first one. Equals to, we know a property. So look, adjoint of adjoint A equals to determinant A square into A. This is our well-known property. Adjoint of adjoint A. Determinant A into A. Sorry, determinant A into A. Now, adjoint of adjoint A, determinant A into A. Now, this is determinant A into adjoint of A inverse. Determinant A whole square into adjoint of inverse. So, adjoint A, determinant A inverse equals to adjoint of A by determinant A. So, determinant A. So, what is adjoint of A? Adjoint of A equals to A inverse into determinant A. A inverse into determinant A. So, adjoint of A, if this implies adjoint of A, then inverse. This is inverse equals to into determinant A. Total inverse. Total inverse. So, this is not matrix, this is K into this. So, we have already proved this one is true, this one is true. Now, problem, now condition, option A and B. Now, A into adjoint of A equals to determinant A into I. So, replacing A by adjoint of A. So, this is adjoint of A, adjoint of adjoint A, determinant adjoint of A into I. So, determinant of adjoint A equals to A square into I. So, this is A square. So, what is adjoint of A? So, this one, determinant A square into adjoint of A whole to the power minus 1 into I. So you are getting this one. So option B also correct. So this is A. So this is not correct. So this is problem purely based on theory. So theory of adjoint matrix. Now problem number 3. A into adjoint of A. A into adjoint of A equals to 10, 0, 0, 10. So 10 into 1, 0, 0, 1. So this implies determinant A into I by well-known property A into 1, 0, 0, 1. So what is determinant A? Determinant A equals to 10. So what is value of determinant A? Determinant A equals to 10. So using basic theory, you can solve this problem. Now we consider 3 basic problems. These are of 1 marks or 2 marks problem of Wbjee. So consider problem number 9. A is a 3-order matrix such that 5 into adjoint of A equals to 5 into adjoint of A equals to 5. 5 into adjoint of A equals to 5. So we use this theory. K is a constant, then this is K to the power n into determinant A, where A is n into n matrix. So adjoint of A is a matrix. So it is 3 into 3. So we can write it 5 cube into adjoint of A. 5 cube into adjoint of A equals to 5. Now this is 5 cube. So determinant A to the power 3 minus 1 equals to 5. So determinant A square 1 by 25. So determinant A equals to plus minus 1 by 5. So 1 marks or 2 marks problem. Using this theory, an adjoint of A, determinant A to the power n minus 1. Now problem number 8. Adjoint of adjoint A square. So adjoint of adjoint A, we know this is determinant A to the power 3 minus 2. This is A into A. 3 minus 2. So replace A by A square. So adjoint of adjoint A square equals to determinant A square into A square. Now take determinant on both sides. Adjoint of adjoint A square. Total determinant. Determinant A square into A square. So A is of the order 3. So order 3. So this is scalar. Mod A square is scalar. So mod A square power is 3 into determinant A square. So this is mod A to the power 6 determinant A into determinant A. So determinant A to the power 8. So look it again. Adjoint of adjoint A square. So adjoint A square to the power 3 minus 2. That is 1 and A square unchanged. Then K into determinant A equals to K cube. Order is 3. So this is constant. This plays role of K into this. Determinant A square. Determinant A into determinant A. So A to the power 8. Now consider problem number 6. A is a square matrix of order 3 such that determinant A equals to 0. Then what is determinant of this? Determinant of AB, you know, this is determinant A into determinant B. So this is determinant A to the power 3 minus 1 into determinant A. So determinant A cube equals to 3 cube equals to 27. So determinant AB, if A and B are square matrix of same order, then this theory. So these are fully based on basic theories. Now we consider two problems of JEE main. So the adjoint of 3 into 3 matrix P is this. Then possible value of determinant A is this. The adjoint of 3 into 3 matrix. Then possible value of determinant, I think this is P. Then possible value of determinant P. So adjoint of P equals to this. Adjoint of P equals to this. Now taking determinant, adjoint of P equals to determinant equals to 144, 217, 213. This implies determinant P to the power 3 minus 1 by well-known property. Now what is expansion? 1 into 3 minus 7 minus 4 into 6 minus 14. 6 minus 14 plus 4 into 2 minus 2. So this is minus 4. This is plus 8. So minus 4 and this is 8. So 32. So this is 28. So let us verify. 144, 217, 213. Not 213, this is 113. This one is 113. So this is 113. So 1 into 3 minus 7 minus 4 into 6 minus 7. This is 6 minus 7 plus 4 into 2 minus 1. So what is the value? So this is minus 4 and this is plus 4. This is again plus 4. So this is 4. So what is determinant P? Plus minus 2. So we have already solved this problem. Here you have to calculate determinant P only. So possible value is 2 and minus 2. Next problem number 16. A equals to this, B equals to adjoint of A, C equals to 5A. So determinant C by adjoint of B. So what is C? 5 into A by adjoint of B. So this is 5 cube into determinant A. A is of 3 into 3 order. What is adjoint of B? So adjoint of B. So this is B to the power. So adjoint of, right, value of A, adjoint of A. Adjoint of adjoint A. Now 5 cube into determinant A. Adjoint of A. So determinant A to the power n minus 1 whole square. So 1 to 5 into determinant A by, this is 3. So this is determinant A to the power 4. So 1 to 5 by A cube n minus 1 whole square. Now what is determinant A? Determinant A equals to 2 into minus 3 plus 4 minus 3 plus 4 plus 3 into 2 minus 0 plus 4 into minus 2. 4 into minus 2. So this is 2, this is 6, this is minus 8. So we are getting 0. So let us verify. 3 into minus 3 plus 4 plus 3 into 2 minus 0. 4 into minus 2. So this is 3 into 2, 6. This is plus 1, so 2. So let us verify what is the value of A. So look, what is value of determinant A? Determinant A, this is 3 into, not 2 into. This is wrong. This is 3 into. So 3, so this will be 3. 3 plus 6, this is minus 8. So 9 minus 8 equals to 1. So what is the value? 1 to 5. So this is 4 marks problem of JEE Main. So determinant C. So C 5 into A. 5 cube into A. This step to be noted. A cube into this. And adjoint of B. So adjoint of adjoint A. So well known property. Then put the value of determinant A. This is 1. Now we consider one more problem. So P and Q are two square matrices of order 3 such that P naught equals to Q. So it is given that Q cube equals to P cube and P square Q equals to Q square P. So if you add them, Q cube plus P square Q, P cube plus Q square P. So this is Q square into Q, P square into Q, P square into P, Q square into P. Now Q square plus P square into Q. Matrix multiplication is distributive over addition. So P square plus Q square into P. So now P square plus Q square. So this is commutative into Q. P square plus Q square into P. Now since P naught equals to Q, therefore there is only one option. P square plus Q square equals to null matrix. So what is determinant P square plus Q square? So value is null. This is null matrix. So determinant of null matrix is 0. So this is 0. So here we have used matrix multiplication is distributive over addition. Distributive property. Finally we consider 2 1 marks problem of Wbjee. So inverse. The inverse of symmetric matrix is what? Symmetric, skew symmetric, diagonal, and. So inverse of symmetric matrix. So let A is symmetric. Therefore, A transpose equals to A. Now inverse of symmetric matrix. A is symmetric. So A inverse. Inverse. What is A inverse? Inverse of symmetric matrix. So A inverse. It is symmetric or skew symmetric. We consider A inverse. Suppose B equals to A inverse. So what is B transpose? A inverse into transpose. So this is A transpose into inverse. Property of inverse. Now what is A transpose? A. So A to the power minus 1, this is B. So B transpose equals to B. So B is symmetric. So this is theorem. The inverse of symmetric matrix is symmetric. Now second one. The inverse of diagonal matrix is what? Inverse of diagonal matrix. Diagonal. Suppose D is a diagonal matrix. D1, 0, 0, 0, D2, 0, 0, 0, D3. So what is determinant D? D1, D2, D3. D1, D2, D3. Or you consider second order. So this is 1 marks problem. So this is D1, D2. So inverse, DA inverse equals to determinant D by adjoint of D. So what is adjoint of D? So this is D2, this is 0, this is 0, this is D1, then transpose. This is D1, D2. Now D1, D2, this one is D2, 0, 0, D1. So dividing each element by D1, D2. So 1 by D1, 0, 0, 1 by D2. So this is again a diagonal matrix. So inverse of diagonal matrix is diagonal. So today, through this video, I have solved some simple and important problem regarding adjoint of matrix. So you complete rest of the problem from description box. Thank you for today.